A warm greetings to one and all. In this session, let's learn about Bayesian Belief Network with a solved example problem. Yes, as a part of introduction, we all know that the probability refers to the likelihood of an event occurring. It is represented by the number between 0 and 1. Rare events have probabilities close to 0 and common events have probabilities close to 1. Probability helps in making predictions and decisions under uncertainty. Probability can be understood in two ways, namely objective, which is mainly based on the actual data or events. The next one is subjective, which is mainly based on beliefs or past experience. It is also known as Bayesian probability. Bayesian probability predicts the likelihood of future events using prior knowledge or new evidences. It is also useful for decision making under uncertainty. Example for Bayesian probability is predicting if a cricket player will be selected based on the matches played, performance, and role which he chooses, that is, either a batsman or bowler. It helps in understanding model relationship and infers the outcome. Proposition is a statement that can be either true or false. For example, is the batsman out? It may be either true or false. Random variable represents unknown values in the format of Boolean, discrete, or continuous. Next, hypothesis is an educated guess or explanation for a phenomena. The logical structure for hypothesis is if A, then B. Here, A is also known as antecedent, which is the hypothesis, and B is called as consequent. Example, if a prisoner learns a skill in prison, they are less likely to commit a crime. A good teacher can increase the student's satisfaction. The testing hypothesis can check if the hypothesis is valid using the data or experiments. Now let's learn about types of probability. The first comes classical probability. It is also known as a prior theory of probability. It is applied when all possible outcomes of an experiment are equally likely. The formula is probability of A is equal to number of favorable outcomes divided by total number of possible outcomes. Example, in a dice roll, the probability of getting a 4 is 1 by 6. Only one side shows 4 out of 6 sides in a dice. Next, joint probability. Probability of two or more events happening together is called joint probability. It is represented as probability of A, B. Example, probability of it raining and you can carrying an umbrella. Next, marginal probability. The probability of an event occurring regardless of other event is called as marginal probability. It is calculated by summing up joint probabilities. Example, probability of it raining, ignoring other factors. Next, prior probability. The initial probability based on belief or prior probability without new evidences is called as prior probability. Example, probability of a student passing a test based on their past performance. Next, conditional probability. It is a probability of an event A happening given that another event B has already occurred. It can be written as probability of A given B. The formula for conditional probability is probability of A given B is equal to probability of A and B divided by probability of B. If A and B are independent, then probability of A given B is equal to probability of A or probability of B. The next type is posterior probability. So it is a conditional probability updated after considering new evidences. It is often used in Bayesian analysis. Example, initially the probability of the batsman getting out, that is the prior probability is 0.3. After knowing that batsman was injured or facing the best bowler, that is the new evidence, the probability might increase, which is called as posterior probability. Whereas the conditional probability, the posterior probability can be as probability of out divided by injured. So it is the probability of batsman getting out given here she is injured on previous ball. Now let's learn about product rule and Bayes theorem. Product rule relates the conditional probability to joint probability. That is, probability of A comma B is equal to probability of A given B into probability of B. Conditional probability for probability of B given A is probability of B given A is equal to probability of A comma B divided by probability of A. Applying product rule, probability of A comma B to conditional probability of B given A, we get Bayes theorem. Probability of A given B is equal to probability of B given A into probability of A divided by probability of B. Here, probability of A given B is posterior probability, probability of B given A is likelihood, probability of A is prior probability, probability of B is evidence. Bayes theorem helps in calculating the probability of hypothesis based on the given evidence. So this process is called as Bayesian inference. Now let's learn about Bayesian networks. Belief network or Bayesian network is a graphical model representing random variables and their conditional dependencies. It uses a directed acyclic graph structure with nodes and directed edges. Nodes represents the random variables, edges shows the dependencies between the variables. Parent node is a variable on which another variable depends on. Parent node is also known as cause. Child node is another dependent variable and it is called as effect. Nodes without a connection are independent nodes. Each function has a probability function using the parent values to calculate the probabilities. Joint probabilities are represented using the conditional probability table, that is CPT. Now let's have an example for Bayesian belief network. In a sports team, the selection of Rohit depends on whether Dravid is coach. The probability that Dravid is coach, the probability of Rohit being selected if Dravid is a coach, and the probability of Rohit is being selected if Dravid is not the coach are given. So we need to find the probability that Rohit is selected using Bayesian belief network. The probability of C, that is probability that coach's Dravid is given as 0.9, and probability that no C, that is the probability that the coach is not Dravid is given with the value 0.1. Next, the probability of Rohit being selected in the team is calculated using the formula P of R. It is represented by P of R given C, that is probability of selecting Rohit given coach's Dravid into probability of coach's Dravid plus probability of selecting Rohit given the coach is not Dravid into probability of coach is not Dravid. So the probability of Rohit is selected such that the coach is Dravid. So the value is 0.8. So 0.8 into probability of coach is Dravid. So the value is 0.9, which is given in the table. So 0.8 into 0.9 plus probability of Rohit given the coach is not Dravid. It is 0.1. Then probability of coach is not Dravid is given as 0.1. Therefore, 0.1 into 0.1. So now we need to add 0.8 into 0.9 plus 0.1 into 0.1, which is equivalent to 0.73. Next, we need to find the probability that Dravid is coach given that Rohit is selected. So for this, we can use Bayes theorem. Here, probability of C given R is equivalent to probability of R given C into probability of C divided by probability of R. Here, probability of C given R is probability that coach is Dravid given that Rohit is selected, which is equivalent to probability of R given C. That is, probability of player is Rohit given that coach is Dravid. So the value for this is 0.8, which is given in the table. And then probability of C, that is, probability of coach is Dravid, which is P of C, is given in the value of 0.9 in the table, which is divided by P of R, that is probability of Rohit being selected in the team, that is 0.73. So we can substitute here, that is 0.8 into 0.9 divided by 0.73. We obtain the value 0.98. So the result, probability of C given R is equal to 0.98, means there is a 98% chance that Dravid is the coach if we know that Rohit is selected. So hope you are clear in Bayesian belief network with this example problem. Thank you all.